Welcome to another episode of A10X, brought to you by 10 Leaves. Imagine stepping into the backseat of a completely autonomous vehicle, right? Like you're on a chaotic, rain-slicked city street.
Yeah, the kind of conditions that make even human drivers nervous.
Exactly. You sit back, the doors lock, and the car just, merges into heavy traffic. And as a sophisticated consumer of technology, you already know the vehicle's being piloted by a highly advanced neural network.
Right, it's taking in, I don't know, millions of data points per second.
Yeah, from the LiDAR, the radar, the cameras, all of it to navigate safely.
Yeah.
But what happens when that system makes a sudden, inexplicable decision? Like suppose it violently swerves across 3 lanes of traffic and just comes to a dead stop.
That is a terrifying thought, honestly.
It really is. And if the company operating that vehicle tells you, well, we aren't entirely sure why it did that, the system is just too complex to unpack, you would likely never get in one of their cars again.
Oh, absolutely not. You demand some kind of verifiable record.
Yeah.
Because the tolerance for that opacity just drops to zero when the stakes move from the digital realm into the physical world.
And that tension, that exact tension, is why we are here today. We are taking you on a deep dive, custom tailored for you, specifically designed to cut straight through the compartmentalized jargon that usually separates the different factions of the tech world.
Because usually those communities are completely isolated from each other.
Right, they really are. So our sole focus today is this incredibly dense, highly concentrated excerpt titled The Trust Layer, where AI meets blockchain. It's noted in our sources as episode 39. And we're looking at this paradigm shift where these two massive, distinct architectures are no longer operating in silos.
Right. They are combining to create this unified trust layer for autonomous systems, and it forces a complete reevaluation of system design, really.
Okay, let's unpack this. Because to really get that aha moment and understand the mechanics here, we have to look at the structural friction between these two technologies, right? And how they manage to synthesize.
Yeah, because for the longest time, the people building these architectures were solving entirely different problems.
Right.
Like one side was obsessed with probabilistic pattern recognition and speed. That's the AI side. While the other side, the blockchain folks, they were hyper-focused on deterministic verification and immutability.
So smashing them together isn't just a basic integration.
No, not at all. It creates a brand new foundational capability for autonomous systems. The source distills their roles quite elegantly, actually. AI makes the decisions, and blockchain ensures those decisions are transparent and verifiable.
Yeah, and the brevity of that distinction kind of hides a massive engineering leap, doesn't it?
It really does. We know that neural networks operate probabilistically. They are mapping these complex multidimensional spaces, weighing variables, and generating an output that represents the highest probability of success based on their training.
But that sheer complexity inherently resists auditing. Like, it's a black box.
Exactly. It's notoriously difficult to audit.
So to help visualize the mechanics of this partnership, let's think of it as a corporate dynamic. You can view the AI as a highly visionary, fiercely intelligent executive at a massive global firm.
I like that analogy.
Yeah, so this executive is making thousands of split-second, highly complex strategic choices every minute. They are analyzing market trends, shifting assets, reallocating resources at, lightning speed.
But like many brilliant executives operating on instinct and massive data absorption, their internal reasoning isn't always easily translatable to the board of directors.
Right, exactly. The executive just issues the command.
What's fascinating here is how the secondary architecture fundamentally changes that dynamic without bottlenecking the executive speed.
Oh, right, because you don't want to slow down the AI.
Precisely. To continue your analogy, the blockchain isn't a micromanaging boss telling the executive what to do. It acts as an incredibly meticulous, unalterable auditor standing parallel to the decision-making process. Ah, okay, so it's not in the way.
Right. It doesn't interfere with the generation of the probabilistic output. But the moment that decision is executed, the auditor cryptographically seals the inputs, the operational parameters, and the final output onto a chronological, immutable ledger.
And that solves a major structural problem. We aren't attempting to record every single microscopic weight adjustment inside the neural network.
No, because that would require an impossible amount of computing overhead.
Yeah, it would completely grind the system to a halt. Instead, we are anchoring the critical boundary conditions of the decision to an unalterable record. So if the executive says, move $10 million to this account, the auditor logs the exact market data the executive was looking at the time of the decision and the execution order itself.
Right, in pen. with no possibility of a shredder ever being used.
Yeah, a permanent receipt. Which brings us back to your autonomous vehicle scenario. The sheer velocity of AI decision-making creates an inherent vulnerability, right? It does. The inability to trace causality post-event. By tethering the AI's outputs to a distributed ledger, you essentially create a permanent, tamper-proof flight data recorder.
So the AI provides the agency, but the blockchain provides the chronological anchor.
Yes. So if the car swerves, we don't have to rely on the manufacturer's internal, potentially alterable server logs. The decentralized ledger holds the cryptographic proof of exactly which sensor inputs triggered the routing algorithm at that precise millisecond.
Wow. It removes the requirement to inherently trust the entity operating the AI.
Totally. The verification is outsourced to the mathematics of the ledger. And that systemic shift is what ultimately enables autonomous systems to operate in high-stakes environments.
Which flows perfectly into the core thesis our brief points toward. The culmination of this dynamic, the AI deciding and the blockchain verifying,
Right.
creates a state where, to use the exact phrasing from the text, trust becomes programmable.
Programmable trust, it's a heavy concept.
So what does this all mean? Because I have to push back on that phrasing, honestly. When we talk about trust, we are generally talking about a psychological state. It's a deeply human, messy, emotional vulnerability.
Oh, for sure. It's a gut feeling.
Right. You trust a colleague to follow through on a project, or you trust a friend with a confidence. To call a profoundly human condition programmable almost feels like an oxymoron. It feels like applying a mechanical framework to an organic process.
Well, it requires a strict separation of interpersonal trust from institutional trust. You are absolutely right that interpersonal trust is organic and psychological. But the trust the brief is referring to is systemic.
Systemic trust.
Yeah.
Okay.
Think about how modern civilization currently scales trust. You don't know the pilot flying your commercial jet, and you don't know the CEO of the bank holding your mortgage.
No, I definitely don't.
Right, but you rely on a massive, complex web of regulatory frameworks, compliance audits, and legal recourse to enforce reliable outcomes.
So we trust the scaffolding around the transaction, not the individuals executing it.
Precisely. But historically, that institutional scaffolding has always required human intermediaries. We use human auditors to check the books, human regulators to inspect the factories, human lawyers to enforce the contracts.
And humans make mistakes. Or they lie.
Exactly. Programmable trust argues that we can strip the human fallibility out of the verification process entirely.
Okay, I see the distinction now. We're moving the burden of verification from human institutions to cryptographic consensus. But that brings up a really complex systemic question. How do you actually hold a decentralized algorithm accountable?
It's a great question.
Because you can't subpoena a neural network.
Right.
Right. You can't put an autonomous routing system on the witness stand.
Right, but accountability in a programmable trust layer doesn't mean punitive action against the machine. It means deterministic recourse.
Deterministic recourse. Meaning what exactly?
It means that the logic of the system can be unspooled and verified post-mortem with mathematical certainty. Right now, when a massive corporate failure occurs, forensic accountants can spend years trying to piece together who knew what and when.
Oh, yeah. Documents go missing, memories fade, servers are conveniently wiped.
Exactly. The friction of auditing is incredibly high. But if accountability is baked directly into the code, like if every parameter change and every output is cryptographically sealed the moment it occurs, the friction of auditing drops to zero.
Because the record is already there, perfectly preserved.
Yes. Trust becomes programmable because the capacity for deception is structurally removed from the system. You don't have to trust the developer, you don't have to trust the corporation, and you don't even have to trust the AI itself.
You only have to verify the cryptographic proof on the ledger.
Precisely.
Man, it is a profound inversion of how we interact with technology.
Right.
We currently live in a trust us, our systems are robust paradigm. And this trust layer shifts us into don't trust us, verify the proof yourself paradigm.
And the brief makes it very clear that this isn't just an abstract philosophical exercise happening in white papers.
Right, the systemic applications are already scaling. The source explicitly targets supply chains and finance as the immediate arenas where this trust layer is altering operations.
Yeah, they are the perfect test beds for this.
Here's where it gets really interesting, because looking at those two specific industries reveals exactly why this technology is necessary. Let's look at global supply chains first. The sheer complexity of moving physical goods across borders is just staggering.
Oh, it's an administrative nightmare.
It really is. You have manufacturers, freight forwarders, multiple customs jurisdictions, port authorities, local distributors. It is a highly fragmented ecosystem that survives on an astonishing amount of friction-heavy paperwork and blind trust between isolated data silos.
And wherever you have isolated data silos and physical handoffs, you have massive vulnerabilities for inefficiency and dispute.
Yeah.
Consider a shipment of highly sensitive, temperature-controlled pharmaceuticals moving from a manufacturer in Switzerland to a hospital network in Chicago.
Okay, so high stakes. If that shipment arrives and the chemical compounds have degraded because the temperature dropped below the required threshold, the current system just descends into chaos.
Complete chaos. The local distributor points the finger at the shipping line blames a delay at customs blames the trucking company.
Because everyone has their own internal isolated records, and none of them align. So the manufacturer ends up eating a massive financial loss, while the dispute is tied up in arbitration for months.
Right. Now apply the trust layer. Let's introduce an autonomous logistical network where an AI is actively managing the routing.
Like a self-driving supply chain.
Exactly. The AI is optimizing the path in real time, pulling in weather data, port congestion metrics, and fuel costs, making thousands of micro adjustments to the supply chain flow.
But the AI is tethered to the blockchain. The ledger serves as an uncheatable, universally accessible shipping manifest.
Yes. If we connect this to the bigger picture, the mechanism here fundamentally eliminates the dispute phase. As that AI-managed shipment moves, IoT sensors inside the container are continuously hashing the temperature data, and the GPS coordinates directly onto the blockchain.
Okay, so if the AI decides to reroute the truck due to a storm, that decision and the weather data input are logged immutably.
Exactly. So when the degraded pharmaceuticals arrive in Chicago, there is no arbitration. The involved parties simply query the shared ledger.
Wow. The cryptographic proof shows exactly when and where the temperature threshold was breached.
Yes, what the AI routing logic was at that exact moment, and which entity had physical custody of the container. The accountability is absolute.
That's incredible.
And the trust layer doesn't just record the failure, it acts as a forcing function for better behavior across the entire network, because every participant knows that their actions are being permanently, transparently verified. It strips the friction out of global trade.
It essentially acts as an automated infrastructural lie detector test that constantly runs in the background of global commerce.
That is a great way to put it.
And if supply chains represent the movement of physical assets, the brief's other major example, finance, represents the pure movement of digital assets, which is arguably an even more volatile environment.
Oh, without a doubt. The financial sector is the ultimate proving ground because it is entirely constructed on institutional trust. And right now, algorithmic trading dominates the markets. Massive hedge funds and institutional investors deploy proprietary AI models to execute high-frequency trades.
Right. These systems are digesting global news sentiment, satellite imagery of crop yields, and microscopic price fluctuations, executing millions of decisions in fractions of a second.
And they are the ultimate black boxes. They are moving billions of dollars before a human trader even blinks.
And that creates a regulatory nightmare. When a flash crash occurs and billions in market value evaporate in minutes, regulators are tasked with figuring out what happened.
Good luck with that.
Right. But trying to audit a swarm of competing proprietary high-frequency AI models using traditional forensic methods is essentially impossible. It's like trying to catch a speeding bullet by analyzing the wind currents it left behind days later.
By the time the SEC or the CFTC demands the logs, the AI models have mutated their weights and executed a billion new calculations.
Exactly. So how does the trust layer fix that?
Well, implementing the trust layer changes the regulatory framework from a forensic reactive model to a real-time programmatic compliance model.
Oh, interesting.
Yeah. If every algorithmic trade, along with the specific data inputs that triggered the execution, is required to be hashed onto a decentralized ledger, the market gains inherent transparency.
You essentially force the black box to leave an unalterable paper trail. So the AI can still operate at blinding speed, and the proprietary strategies can remain encrypted, but the execution logic and the timestamps are permanently anchored.
Yes. Regulators wouldn't need to launch month-long investigations. They would simply run verification scripts against the ledger to identify market manipulation or collusion with absolute mathematical certainty.
Wow. You ensure that autonomous financial systems are bound by the rules of the market because they lack the architectural capacity to hide their actions.
The trust is programmed into the infrastructure itself. We ensure that as our systems become exponentially more capable and autonomous, they do not become exponentially more opaque.
So to synthesize this entire deep dive for you, let's step back and look at the unified architecture we've explored today. We started with two distinct technologies that are almost always analyzed in isolation, but by integrating them, we overcome their individual structural weaknesses.
Right, the artificial intelligence acts as the engine of the system. It processes massive data sets, it navigates complex environments, and it makes high-velocity decisions.
And the blockchain acts as the anchor. It meticulously records, it inherently verifies, and it ensures absolute immutability. Together, they form a programmable trust layer.
They remove the anxiety of relying on opaque autonomous machines by turning accountability into a mathematical guarantee.
And as we've seen, this is already beginning to strip the friction out of incredibly complex, high-stakes industries like global supply chains and high finance.
The synergy allows us to scale autonomy safely, and supply chains and digital finance are merely the testing grounds. The logic of this architecture can be applied to almost any system that requires verifiable outcomes.
Which perfectly tees up the rather stunning provocation that our source material leaves us with. The brief ends with a very specific teaser. Next construction gets automated.
Yeah, that line really caught my eye.
Right. Think about the implications of that. We've spent our time today discussing data routing, digital asset transfers, and tracking shipping containers.
Right.
But applying a programmable trust layer to the physical fabrication of our environments. I mean, imagine autonomous cranes, AI-driven architectural resource allocation, and robotic fabrication, all continuously verified and audited by a decentralized ledger in real time.
It's wild to think about.
It signals that the physical world, the literal building of our cities, is the next massive frontier for this technology.
It signals a complete integration of digital accountability into physical infrastructure. But, as we reach the end of our analysis, I want to leave you with a broader, more philosophical thought to mull over.
Oh, absolutely. Let's hear it.
Throughout this deep dive, we have examined the mechanics of programming perfect, verifiable trust into our machines. We are actively designing architectures that demand our autonomous systems be entirely transparent and flawlessly accountable.
Right.
If we are successful in deploying this trust layer at scale, we will spend our days interacting with systems that possess mathematical certainty. We won't have to guess why a decision was made, and we won't have to worry about records being altered to hide a mistake.
Yeah, it sounds like a utopia.
It does. But the question is, once you become accustomed to that level of absolute transparency from your technology, will your standards for human trust begin to change?
Oh, wow.
When you get used to interacting with flawlessly accountable AI, will you start expecting the human institutions in your life, your local government, your bank, or even your professional colleagues, to be just as transparent? Will we eventually demand that our human systems operate with the same verifiable, immutable accountability that we have programmed into our machines?
That is a phenomenal question. Does the architecture we build for our machines eventually become the standard we demand of ourselves? That thought is going to resonate long after this deep dive is over. Thanks for joining us for another episode of AI 10X, brought to you by 10 Leaves.